so didn't. But what else do we have? Okay, should I go? I can go ahead and make enums for the whole grammar probably. So that's whatever. Hmm. Nah, I'll come back to that. All right. So for now, sort of, what are we trying to make?
For now, we're just dealing with the expressions.
Yeah. All right. So test parse expression.
Yep.
Okay. So let's say
A plus 1, 5 plus 5. Yep.
see anything else like identifiers, or I guess that comes later.
We can add more tests later.
All right, so scan it, and then we'll get something. All right, yeah, I'll just do that. Okay. So here is the sequence of tokens.
Seems reasonable. We don't really care about the sequence itself. We want to change it into expression.
Yeah. All right. So tokens, and then parser equals, and I don't think I've made this yet. Let's see, how do I pack all the enums up? Before we just had one enum.
I think we want a method on expression. A method is going to be called parse. It takes a reference to slice of tokens and produces a result, expression, and unused tokens, or it takes mutable slice to tokens and produces result expression. So we will have to parse different items from the token stream. So we need to be able to consume them separately.
Right. Okay. So the way that he did it is, so I think yeah, he does have he has a parser class, an expert expression. So he had like a separate operation for each type of expression. Um,
I think we don't need that. Can make it simpler.
um, okay. So, um, I guess that what this does is it figures out if you know that you're trying to parse a comparison, this picks out the correct number of tokens that fit into that and returns the comparison here. So it'll do that for us. So you're right. I'll make this parse. Hmm. What's the slice? Sorry.
Slice of braces and token capitalized.
Okay. Um, okay, we do have a thing called a token. Cool.
And this gives a result self or option self. Mm,
Okay. Um, so let's do, are we going to match the type of expression here?
we check what token I have at the front.
Okay. So t equals,
I would use get because index operation will explode when it's empty.
yeah.
Get 0 and question mark.
Okay. So,
And on that we can do pattern match, I think.
okay. I guess that, so what I'm curious about is how do we know when to parse this way for a comparison versus an equality? How are we going to eventually call this? Is it from a parser class or not?
Well, on the top level, we will parse whatever the enum you decided not to implement. From that, from the first token, we'll see if it's a function declaration,
Hmm.
if it's a statement or whatever. And from when we have statement, it would be a variable name, then equality sign, and then expression. So we will be calling it for expression specifically.
So I think that we
For now,
are,
we just know that we have an expression And we need to figure out what kind of expression it is.
Where does he get the unambiguous form of the grammar? Is that already here? Um,
Can you ask Rust Analyzer to expand all the possible variants?
Sure. There is.
So I think you need to get rid of this wildcard pattern match and just right click on T.
I don't. It says no quick fixes available. Is it like plugged in correctly? Replug.
I don't know. It shows a light bulb at some point on the left side.
Okay. Ledger fill in.
Well, it's not Rust Analyzer, it's Rust Analyzer and Visual Studio. Yeah.
Fill match arms. That'd be cool.
It already can do that. Now that's the old ticket. Yeah, it was showing the light bulb. Can you click on that? No, not useful.
Okay, well.
I'm pretty sure there should be a way.
Okay. So weird. How come it's complaining about specifically these?
Because all of those.
Oh, it's ambiguous.
Yeah,
Ambiguous. Okay.
you need to use. Well, you need to use expression. Right now, it sees it as a whole bunch of single variable patterns.
Yeah.
And those three are not patterns. So you need, use create token star if you want to do that. And that's not going to work either. So you look at the line 29 and see you're trying to pattern match on left paren. When Rust sees this, it sees that it's a pattern that we decided to call left paren, and it captures
Okay.
everything. So
So
the
unless
rest,
you have to use this.
you can use this, or you can use on line 27, and after that, use space token type colon star.
Yeah. So that imports all of it. Then I still need to
Yeah.
disambiguate the ones that are also this.
Next, we have a slice of tokens. You're doing pattern match on tokens instead of token type. That's why it probably couldn't, because token is a struct.
Okay.
So
Do
that
I need the other things?
it should be able to fill in the details.
Do I need the other? Do I need to include the other pieces of data in the pattern? You think, or just do we only care about the
No.
token type?
I think we care about token type and the rest.
Okay. So it's just Lexine in line. Yeah. Maybe for
we don't
debug.
care about that yet.
Yeah.
So expression can start with left paren.
Mhm.
It can start with plus or minus. It can start with identifier, streak, or number. And I don't think it can start with anything else.
It can start with plus.
Yeah. That should be.
I thought so. So minus can be unary minus or like negation.
Yes.
Also bang, I guess, right?
Yep.
But is plus anything besides a binary operator?
I don't know. No unary plus.
No unary plus.
Okay, well, we don't have to do it either.
Okay, so parens, yes. Braces, not yet. Comma, not yet. No. Plus has to be in the middle. Semicolon,
Nope.
no. And then,
Nope.
Yep.
Bank, yes. Those, yes.
I don't think we're doing
False.
identifiers yet, but we will.
False, yes. True, also yes. The rest are nil. This, I think we need this. No?
Not yet.
Not yet. Okay.
Okay.
And for the rest, we none. Yeah, that works.
What are you talking about?
Guess we return none.
Okay. So if it is a left paren,
This means we recursively parse one more expression.
yeah.
And
So,
then
but we have to
must
consume. We have to remember to consume the right things. Is that basically the idea?
Yep.
So return some, and then the same thing, but with the parentheses trimmed off. Dot
Okay,
parse.
so when we see left paren, we need to parse expression recursively. Then we need to parse right paren, and we return the whatever we parsed recursively.
Yeah.
So that would be one column, I guess.
So question, is it tokens dot?
No, tokens.
Do we have to do anything
square
with
brackets?
this?
We need
Yeah.
to. Yeah.
We assume it ends with a.
But we'll have to parse close and right paren also. So
Yeah.
I think we want to move this parse outside of this return statement and assign the result to some temporary variable.
Okay. So
Let expression result doesn't matter. Yep.
so, but we don't need to do anything with those parens.
We need to make sure that expression that follows after is closing paren. And you need to specify ampersand mute.
Right. Okay.
Mm,
And then this, but okay.
and I think,
So we need to check whether it ends with the right paren, right?
yes.
So is that before here? Like,
No, after. So
how are we going to know when the expression ends?
okay, let's go to line 31. Before the text, we insert let tokens, not let, tokens equals remove let.
Okay.
Yeah, tokens. Yes. And mute. Okay. So each individual parser updates reference to tokens as it goes.
There's some borrow checker thing we're messing up here.
No, it's not a borrow checker. It's
Mutable.
I just insert star before tokens.
Oh,
I think that's
okay.
what it wants.
Size is not implemented. Okay. I want to see it in the full error. Well, that's okay. That cannot assign to immutable argument. So why is it an immutable argument in this scope? I said it's a mutable reference.
Well, it's not mutable, it's immutable reference, so we need star somehow.
Okay, the problem here is remove the borrow.
Doesn't. Okay.
There you go. Size is not implemented.
Let me check what we're supposed to write.
It's a slice though. Isn't a slice always supposed to have same size? Mute tokens.
I think it will be easier if we take tokens as immutable slice and return it as one of the arguments. So something like this, paste it in chat.
Okay. So you'll return the modified set of tokens to work with.
Yeah,
Okay.
the tail.
Interesting. I mean, I like that. I don't know why. Okay, so yeah, now you're returning a different slice.
Yep.
Okay.
You need parentheses inside on line 26, inside option parameters.
Mhm.
Lifetime. Okay. So we need a separate lifetime for so function parse takes can you try token change a token to be this.
Oh, because it also needs a lifetime. Okay.
Yeah. Well, that works, I guess. No, we still need lifetime on the slice itself as well as. I think that's fine. So left paren, we parse expression from tokens, but we need to skip the first token here. So at line 31, we need 1 dot and ampersand in front. And it is as skipping the opening paren. Okay, it will give us back expression and a new set of tokens. And you need to use question mark at the end of this line. And here we check, yeah.
So is this, I guess this would be some kind of error.
Yes.
We're still panicking. I think we are. We're saying right paren.
And that's why it might be useful to use the result instead of option. But for now, yeah,
Okay.
Let's make the basic expression, see how it works.
Sum of a tuple of expert, and then
Yeah.
also take
we
out the
need to
right
skip
paren, right?
close and paren.
Yeah.
No. Tokens we have here is already this expression removed, so we need to skip close and paren. So ampersand tokens 1, yes.
Okay.
And that seems fine.
Okay.
So what
that's
we have in our test case is are those all numbers?
Yeah.
Yeah.
We can't. We have to get down
We
to a
can
base
test
case eventually.
Number in parents.
Well, we don't know what to do with a number, right?
Not yet.
So we have to do
Let's
at least one of
binding
the base
there.
cases. All right. So if it's a number,
we just produce the expression with number inside, and that's it. And we drop the one token from the result.
sum create expression number of n, and then none, or empty list or something.
It's again ampersand tokens 1 dot dot.
Oh, right, because we don't know anything about the rest of the tokens. We don't know.
We don't really care about it. You need one more set of parents because.
Okay.
Yep. So the test should pass now. Well, not pass, to something.
It's yeah, whatever.
You can use unwrap and dot zero, for example.
We need to use the expression types. Okay, need to derive some stuff on an expression. Can I kind of steal the same things we had to do for?
Just we need debug, we need equality, copy, no, clone, not copy. Cannot have copy.
Yep, and then it has to virally spread to all this other crap. Okay, now are you happy? Yeah.
Oh yeah, all the numbers are floating point numbers.
Didn't I say that? F64. Are we parsing it as
you
an int?
used a string numeric literal, integer numeric literal, so it needs to be 3.0.
Why didn't it fail here?
In the expression you compare with, it says number 3.
Gotcha.
And
Okay.
it works.
Nice. How long that took us? 45 minutes to do one of them. It's okay
That's
though.
fine. It's a learning process.
Yeah. All right. Let me see if there's any other easy ones.
If we have right paren, it's not correct either.
Yeah.
I can try minus, can try bank.
Mm-hmm. All right. So his unary thing. And so we're not we're going to pick off the beginning symbol.
So when we see unary minus, we parse the next expression and just use that and negate it. If it's number in any shape or form, it works. Otherwise, it will fail on type checking. If I try to negate a string, for example.
Hold on a minute, because when you parse a unary expression, it's only the thing is only allowed to be either a unary or a primary. It's not allowed to be a general expression. So how is this working? Sorry. This is why he has the different methods for different types of expressions. So how would it work for us? If we just recursively call expression.parse instead of unary.parse or something like that?
Well, we can parse unary. I imagine you can negate pretty much anything that is not a string. Like a minus parens 1 plus 2, paren closes. I expect it to evaluate to minus 3.
So that's only if it's a grouping. So if you have
Yes.
minus and then some binary operator,
Oh,
right?
okay.
Um,
Yeah, we can add.
right. The parse rule has to reject, or it has to know to only parse the 2 and not the 2 plus 3.
Okay. So let's add expression parse unary.
Okay.
Method to expression called parse unary.
All right. So we're not doing a unary dot parse. We're not doing a, because we could also do this.
We don't have unary. We don't need it.
Unary operator. Yeah. Okay.
Operator is different.
So we'll have one of these per level in the grammar. Then is what we'll end up with.
Yep, that seems reasonable. So same type signature.
Okay. Now this is going to end up with a lot of duplication, isn't it? We're doing an exhaustive
Inside
like.
the unary, we can have bank, we can have minus, and we can have primary. So there will be some duplication for.
Okay, so maybe we can just, if it's minus or bang, we can just call parse unary, or like pick off the minus sign and then parse unary.
Yes, sounds reasonable.
Wait, let me think. So are
Uh,
we,
we
do you want to pick off the minus and bang
we
in
can
this?
try to follow. We can try to follow the structure he writes if we follow this unary, and it seems to work for us.
Okay. Um, sure. So this can only start with the minus or a bang.
Yep.
Um, so turn some expression unary operator, unary operator minus, and then right is parse. I think we need to do this separately.
Recursively.
But so here's I guess the thing is it's not an expression that we're parsing here. It is a unary.
It can be expression. We just know its type.
Unary or primary. Okay, so we have to take off the first token.
Yep.
So tokens at 1 onward. And then that is either a unary or a primary.
Yes, so either call itself recursively or call to parse primary.
Okay, which one though? So if you call yourself recursively, how do you know when you're in the case where you need to parse a primary? If I call myself recursively here.
Well, you call yourself. You parse primary when it's neither a minus and no bank.
Okay, return parse primary.
Yes.
Tokens. That works, I think. We're probably gonna end up doing a similar thing here then, right?
Yeah.
Yeah.
We can probably get rid of all those returns and just well, doesn't really matter. We can
So
simply
this will end up being in parse primary, I think.
yes. And not the yeah, parents as well.
Yeah. Okay. This makes more sense to me. So there's one of these parsing functions per level. And each time we're checking. Oh, we haven't had to deal with the star yet. But and it can be any number. Is that easy?
Yeah, we call ourselves recursively, and
Okay.
we try to call ourselves recursively again, collecting stuff.
I think we'll probably end up doing a loop like he does.
Yeah, maybe.
Okay, cool. So I'll make the rest of these signatures, and then we can pick up there next time.
Okay.
And that we sort of gotten the framework. Sparse term. Okay. That'll be that. Right is a box, and right, we now have to use box, I think. Okay. Right, and then this is just the expression, so now we need to pass the rest of the tokens. Great. What's this mean? Self. There. Okay.
Gating somewhere.
Yeah. What did he say?
Somewhere.
Okay.
We're getting somewhere.
Yeah. I think it's straightforward what to do from here. We just needed to figure out like the structure. And let's say I can also, right before we leave, put in the token types we have to care about at each level. So let me order these correctly. Person, term, factor, unary, primary. The primary we have to do number, string, true, false, nil, left paren, right paren. Okay, here it's minus bang. Here it is slash and star, whatever we call those. Here it is minus and plus. Here it is whatever. These. Here it is not equal. All right, and these we don't have because they will be in primary. Oh, and I think EOF also goes in primary, right? Because you'll end up recursing down to that level.
if that's end of the file, I don't think it's an expression.
Yeah, but we have to decide what to do with it in the parser, right? So let me see what
File.
he does. So he has a helper function called is at end that he calls all over the place.
Well, I don't think I need it.
Yeah, we'll handle that. Okay, cool. Why are you saying my comments are illegal? Oh, it's trying to parse them as dot comments.
/ exclamation mark.
Yeah. Okay, cool. All right. Well, we will get him next time.
Yep.